Hi everybody, welcome back to Viral Integrals. So this integral is called the Sophomore's Dream. It looks strange because the exponent is changing with x, but the main idea is to rewrite x to the negative x as an exponential, then let a familiar series do the work. So the first move is to turn the variable power into e to a logarithm. Since a to the b is e to the b log a, x to the negative x becomes e to the negative x log x. Now we check the input of the exponential series. On the interval from 0 to 1, log x is negative, so negative x log x is positive. Its maximum is 1 over e, so the series input stays controlled. And displayed are the calculations you would need to show that. Now here's the new move for this video. What we're going to do is use the exponential series and integrate it term by term. The reason this is safe here is that the input stays bounded on the whole interval. Now substitute negative x log x into the exponential series. This turns e to the negative x log x into a sum of powers of negative x log x divided by n factorial. And because log x is negative between 0 and 1, it is cleaner to write negative x log x as x times negative log x. So the nth power separates into x to the n times negative log x to the n. Now the integral moves through the series. The original integral becomes a sum, and inside the sum we get 1 over n factorial times the integral from 0 to 1 of x to the n times negative log x to the n. The same kind of integral appears in every term, so we isolate it and call it a sub n. Once we evaluate a sub n, we can plug it back into the main series. The substitution is chosen to make the x to the n and dx part collapse cleanly. Let u equal n plus 1 times negative log x. Then x to the n plus 1 becomes e to the negative u. Now translate the pieces. X is e to the negative u over n plus 1. Dx picks up another copy of that exponential, and the bounds change from x equals 1 and 0 to u equals 0 and infinity. And here's the payoff from the substitution. The x to the n and the dx combine into 1 e to the negative u, with a factor of 1 over n plus 1 outside. And the remaining log factor also converts cleanly. Since negative log x is u over n plus 1, the whole a sub n integral becomes 1 over quantity n plus 1 to the quantity n plus 1 times the integral of u to the n times e to the negative u. So the only integral left is this b sub n part. It's the integral from 0 to infinity of u to the n times e to the negative u. And this is exactly the factorial integral from the previous video, just with u instead of x. From the earlier factorial video, we already know that the integral from 0 to infinity of x to the n times e to the negative x is n factorial. The variable name does not matter, so the same result applies to b sub n. That means there is no new integration by parts to do here. We can immediately replace b sub n by n factorial and keep moving. Now we'll return to a sub n. We had a sub n equal b sub n over n plus 1 to the n plus 1. So a sub n is just n factorial over n plus 1 to the n plus 1. Put that back into the original series. The n factorial from a sub n cancels the n factorial from the exponential series, leaving 1 over n plus 1 to the n plus 1. And the last step is just reindexing. If n equals n plus 1, then n starting at 0 becomes m starting at 1, and the denominator becomes m to the m. And there we have it. The integral from 0 to 1 of x to the negative x dx is equal to the sum as n goes from 1 to infinity of 1 over n to the n. Alright guys, well I hope you enjoyed that, and we will see you next time on Viral Integrals.